looking at the polynomial expression 21n cubed plus 15n squared minus 168n minus 120. In order to factor this, we want to first see if there's any common monomial that we can factor out. And 21, 15, 168, and 120 all have a factor of 3. So when I factor that 3 out, I'm left with 7n cubed plus 5n squared minus 56n minus 40. Because 21 is 3 times 7, 15 is 3 times 5, 168 is 3 times 56, and 120 is 3 times 40. So you can see that each one has that common factor of 3, and so that's why we were able to factor that 3 out. Now that we've done that, we want to take a look at the remaining polynomial expression that's inside the parentheses. And I don't see any common factors among all 4 of the terms, so what we're going to do is just take a look at the expression that's inside the parentheses. So if we're just looking at the 7n cubed plus 5n squared minus 56n minus 40, we're going to use the grouping method for factoring. So I'm going to group the first 2 terms into a binomial, and I would group the second 2 like this, but that separates this negative out, which we would then have to distribute, and that would make this negative 56n, which is it's supposed to be. But that would make this second term positive 40, and that's not correct. So what we need to do instead is we need to change this so that we have plus negative 56n. And that will allow us to make sure that we have 2 binomials separated with a plus sign. That's very important. So now we're going to factor what we can out of each set. So the greatest common factor out of the first group is n squared. So when I factor n squared out, what I'm left with is 7n plus 5. And what I can factor out of the second group is a negative 8. And what's left behind is a positive 7n plus 5. And it's important to notice here that whatever the sign of this leading number is, that's the sign that we want to factor out. So since that leading number was a negative, we factored a negative out. And factoring a negative out of a negative leaves us with a positive, and the same thing here. Factoring a negative 8 out of negative 40 leaves us with positive 5. And so it's at this point where I say, do you see what I see? A common factor that we can remove, leaving us with the other factor, leaving us with the other factor. So we have the other factor as n squared minus 8. And this one almost looks like it could be a difference of squares because we have n squared minus something, but 8 is not a perfect square. So it's not a special case, and we are actually finished factoring this polynomial expression, but what we have to remember is that we did factor that 3 out to begin with. So we want to make sure that we have that 3 as a factor as well. So in its totally factored form, 21n cubed plus 15n squared minus 168n minus 120 is going to be 3 times the sum of 7n and 5 times the difference of n squared and 8. And we are finished.